In this section, we're going to do an overview of serverless applications. We will use the AWS console to give you more details about the services we covered in the previous section. Here we have the AWS console that I've logged into, and we're going to see some of the services within the AWS console. Let's review the AWS console. When you first log in, you will see the dashboard. You have a widget for recently visited that will show you the services you recently used. It's a quick way to get to the services that you're working with. Another way to get to your service is to search for it. And you click the service you found, and that takes you quickly to the service you're getting to. If you're working with multiple services, you search for the service you want to work with, right click and open it in a new tab. Now you can quickly navigate between different services. To get back to your dashboard, you click the AWS logo. When you search for a service, you can also make it one of your favorites by clicking the star. Let's favorite S3, and let's favor API Gateway. Now the menu shows you your favorite services right here for quick access. The services menu also has the favorites listed there as well. You can also switch between regions. AWS has various regions. It will, by default, pick the one that's closest to you. Suppose you live in Southern California. Northern California will be the one that's chosen for you automatically. You will need to change it to the region that you want to work with. We're going to use the US East 1 region in all of our examples. That's North Virginia. And that's a quick overview of the AWS console. First, let's start with Lambda. So here in the AWS console, you see I have existing Lambda functions already created. These are some of the Lambda functions that were created while developing the Mastering AWS Serverless book. So let's kind of jump into them. As you see here, the get-chapters Lambda function is one that was written in JavaScript. Down here, you see the code source. Up here, the function overview gives you a visual indicator of how it's working. The Lambda function itself has 0 layers. A layer is a package that you can upload into Lambda so that other functions can borrow this package and use it for their computing purposes. There's a trigger here from API Gateway. So what happens is the API Gateway will send an event or a trigger to the getChapters function, and then it'll return the response. Let's explore the code a bit. So this JavaScript code is designed to get data from a DynamoDB database, as you can see. I'm using the AWS JavaScript SDK version 3, and we're going to use the scan command in the DynamoDB client library. When API Gateway triggers the Lambda function, it sends an event. Here, we're not expecting any information from the event. That's why it's not used in any of the code below. The JavaScript has a response object, which is the response the Lambda function will send back to the API Gateway. Since API Gateway is designed to work with HTTP requests, it therefore needs HTTP response information in on the Lambda function response. So we define a default status code of 500, meaning there's some kind of error. We've defined the headers to allow cross-origin resource sharing, or CORS. We'll get more into this later, but the reason we need CORS is that there's going to be the website, it's going to be on some domain or www some domain, but the API is going to be in a different subdomain like api.mydomain.com. And since they're two different domains, the browsers don't trust that. Therefore, you need to use CORS to let the browser know to trust it. Now, it's good practice to have error catching in your code. So we have a try catch response, or in Python it would be, I think, try except. So if there's any kind of error in the logic, then it'll throw an error. And since we're not modifying the default response, we're sending HTTP code. Lambda then uses DynamoDB client to make a request. So it scans the chapters table, and when it gets a response, it adds the response to the response body. The body is the HTTP response body, and it has to be a string. So we turn this array of objects and we stringify it. You may be wondering why there is no DynamoDB shown here in the function overview, and that's a good question. The DynamoDB is not getting an event from the Lambda function, or the Lambda function is not sending an event to DynamoDB. The way it's interfacing with DynamoDB, it's using the DynamoDB APIs via the JavaScript SDK. It's a direct connection rather than sending an event through the AWS infrastructure for the DynamoDB to respond to. Unlike API Gateway is sending an event to Lambda function and API Gateway is waiting for the response back. That's why DynamoDB is not shown here, because it's not tied together with events or triggers. Here at the bottom of the page, we see more information about how the Lambda function was configured. I wrote the code directly in the editor above. I didn't have to package anything. So the package size is very small. It's under a kilobyte because it's just code up there. And it provides us a hash that we can use for signing. That it's a more advanced feature if you want to protect the runtime of the function, to check the hash first. And if the hash matches, then it'll execute. And if it doesn't, then it'll fail because something's been modified in the code or the package and it's treating it as unsafe code. As mentioned earlier, I'm using Node JavaScript version 20. The handler has two parts. There's the file name, so index.js, and then the second part, the handler, the dot handler, that's the function that AWS is going to run when it executes the function. So when we go back up here in the code, we'll see that I created a handler function, and this file is called, well, it's index.mjs. So it supports .js or .mjs or .cjs, essentially JavaScript files. So the index is from the name, and then the dot handler is the function that it's going to execute. Now the reason you want to specify the function to execute is because you may have multiple functions defined in this piece of code that are support functions. Suppose I had this piece of code as another function down here so that the handler code looks cleaner. Then, so now we would have two functions and AWS wouldn't know which one to execute if we didn't tell it which function to run, unless there's a main in the bottom. The architecture here is ARM64. That's one of the architectures you can choose. And down here, if we had defined layers, we could attach the layers, and there's a specific directory then we can use in the file system of the Lambda function container to access that code or whatever needs to be in there. It could be a binary file, images, etc. Whatever we need for this Lambda function to execute its business logic. So here in the configuration tab, we have additional information. I've set it up to have 1 gigabyte of RAM. So the amount of RAM you allocate will depend on how much memory the function needs. Also, the more RAM that you give it, the faster it can run. And of course, it'll taper out. So if you started off with 128 megabytes, it might take, let's say, 5 seconds to run, but then you increase it to 256, it may take 4 seconds, and then you increase it to 1 gigabyte, then it might take 1 second. But if you increase it to 2 gigabytes, for example, it may only save like fractions of a millisecond at that point, really close to the 1 second. So at that point, you're paying double for very little return on your investment. The timeout is also a good thing to configure. You want to be able to set it to a time close to how long it typically runs, and then also give it some extra time based on if the execution takes longer than normal. The one way to figure it out is just to run it quite a few times and see what the typical duration is. And then let's say it typically runs in 3 seconds, then you can add another 2 seconds, for example, to give it extra time in case there's a delay in processing. Your DynamoDB is taking a while to respond. That gives you some margin. Next, let's explore DynamoDB. I have a list of tables I created for the book Mastering AWS Serverless. Let's jump into the chapters table. Here, the chapters table is where we're going to store some data for the chapters on the website we're going to be creating. As you can see, the table has a partition key or primary key, that's the ID, and it's a number, and it has a sort key, which is a title, what we're calling title, and it's a string type value. I've set the capacity mode to on demand because for this application we're developing, it's just for our purposes. Don't expect much traffic to it. And with on demand, there's no cost when there's no read or write activity. We only have to pay for the storage. Here are the indexes. You can create secondary indexes. So let's suppose there's another attribute in the table that we want to query. So right now we can query anything with ID, and we can also filter on the sort index, which is the title. What about if there's a different property that we want to query on? Let's suppose we want to query on a different property such as chapter number. We would create an index with the partition key being the chapter number, and then we can specify a sort index that we want. We can also monitor, create alarms on things that we want to monitor. So let's say the excess read usage or the write usage exceeds our expected value, then we can create an alarm for it. We can also replicate the table across different regions. We can back up our table, that way we have automated backups and we don't lose any data. We can export our data to S3 as another way of backing up. We can also create what is called a stream. So anytime something is written to the table or updated, it will send an event to our desired destination, which could be a Lambda function. We can also limit who has access to the table. Here we can set the read-write capacity from on-demand to provisioned. So now let's explore the table items. Here I'm going to create a new item. We're going to set the ID to 2 and the title we're going to call it chapter 2. Here you see the created item with ID 2 and chapter 2. With a sort key, which is what we call title, we can actually create another entry with ID and we can give it a different sort key. So the combination of defining a partition key and a sort key allows you to have multiple entries with the same partition key, which is ID here, but different sort keys, which is the title. This gives us flexibility to organize data in a different way. Now we mentioned about a global secondary index. Let's update existing ID 2 entries to add another property. So we're going to add a string identifier and we're going to call it unique ID, and we're going to use a UUID as the value. Now let's modify the other one and we're going to add a string unique ID, and we're going to add another UUID. UUIDs are supposed to be unique and have very low collision rates. So back at the table properties, we're going to go to the index and create a new one. We're going to call partition key unique ID, and we will not use a sort key in this case. And we're going to keep the capacity mode to on demand, and we want to return all the properties when we return the data. So we're going to create that index. And this is going to take a while for it to create. Now that our index has been created, we can start using it. Let's explore the table items. We can get data from a table in two ways, either a scan or a query. By default, the AWS console does a scan of the table. As you see here, a scan is a good thing to do if the table data is small and it's a known size. If it's going to be a large table, let's say it's going to keep growing in size and it's maybe in the gigabytes, a scan can be a very costly operation. Therefore, we should use scans cautiously. We should really rely on queries. We can always query on the partition key. Here we can query on the ID. So we're going to query on an ID equal to 2. We have returned the 2 items have that ID. We can also further query on the sort key. Let's look for a title where the sort key is equal to chapter 2. And we only return that one item now. We can also do string comparisons. If we do a greater than or equal to chapter 2, we should get both items now, because adding an A to chapter 2 makes it greater than or equal to in a string comparison. A sort key and the string comparisons can be useful for properties that contain information such as the ISO timestamp. There you can get all the partition keys that have a certain timestamp greater than or equal to or less than or equal to a certain time. Now let's query on this global secondary index we created, which uses unique ID as the partition key. I'm going to query the item that has that unique ID, which should be the item that's chapter 2A. So now that we've run the query, we see we only get that item because that is the only secondary partition key that has that unique ID value. We can also filter our data on additional attributes or properties. Since this query only returns one item, there's not much to filter. If we query on the ID a 2 and a title greater than or equal to chapter 2, we get the 2 entries. So we're going to filter the response for the attribute unique ID and the value that we just set. So what happened is when we did the query, we did ID equals to 2 and title greater than or equal to chapter 2, and DynamoDB returned all the items relevant to that query. But before it returned the response, then it filtered based on the unique ID equal to the UID that we specified. And only of those 2 entries that were in the first query, only one of them matched, and therefore only returned the 1 entry. So filtering is useful, but keep in mind you still get billed for the initial query, but you're only limiting what you get back. That's useful when you don't want the front end or the recipient of the query to do the work. So for example, rather than having the Lambda function filter out by the unique ID, you can have DynamoDB do it for you. It'll still be the same cost of the operation in DynamoDB, but it may help you reduce the computational time and the cost in the Lambda side. We can also select what attributes we want to have returned in the response. So here we only are going to return the title. As you see, the response only now contains the title. Doing an attribute projection is useful when you want to limit the data that you want to receive by the Lambda function. This is a good security practice because there may be sensitive information in the table entry that the Lambda function should not, or the recipient should not know about. If you only return the data it needs, it improves security and it minimizes the payload size of the response, which reduces the execution time and also the HTTP response time. All right, that's it for DynamoDB for now. In this section, we're going to review S3 buckets. Here we see 3 S3 buckets that we created for the Mastering AWS Serverless book. One bucket is for the website, which is the one that ends with .com. The bucket ending with data is for data created through the web application. The bucket ending with CDK is for information when creating our application using infrastructure as code. Now let's review the bucket for the website. Here inside this bucket, we see files that were uploaded. The index.html file will be the file used for loading the web application. The other files support the website. Let's explore the img folder. Here we see the fave icon.png file, which is the icon showed on the browser tab. The JPEG file is the book cover. Earlier I called img a folder, but really it's not a folder. S3 buckets are not file systems, they are object storage. Object storage uses key value pairs. That means the entire path is the key for the value, which is the content of the file. Let's explore what this means. I'm going to open the .jpeg. The detailed page for this object shows the key. The key is img/mastering AWS serverless book cover.png. The S3 console makes the user experience feel like a file storage because that is what we are used to as users on operating systems. But in reality, they're really just keys and values. If we were to export the list of all the objects stored in a bucket, we will see just the keys. One of the items in that export would be this whole key path that we just mentioned earlier, and then another key would be index.html. So let's explore some of the details. So the URI here shows S3 is the service, the bucket name, and then the key. The Amazon resource name, or ARN, is the unique path that AWS Services uses. This will become particularly helpful when we get to identity and access management. IAM uses the ARN values when defining privileges. The object URL is something we can click on that will show us how the content will appear if the object is public. When I clicked on that, it shows that we do not have access to see. The browser does not show an image, but rather an error code showing that access is denied. The public settings have made this bucket private. A little further down the page, we see that the bucket property shows that bucket versioning is disabled. We want to enable versioning when we want to keep track of the different versions. For this web application, I've chosen not to enable versioning because these are files that could be changing over time, and there are different tools I can use to track the versions. For example, Git or GitHub. There are other properties. We can choose to replicate the objects to a different bucket in a different account in a different default region. We can choose to automatically expire the objects after a certain date. When we expire an object, it becomes deleted after a certain grace period, which could be 0 days. Expiration helps us with lifecycle management for our data. We do not want to keep data longer than we need to. The storage class is how the data is accessed and stored. We can choose a different storage class. Rather than having it standard, which is the most available storage class, also the most costly, we can change it to infrequent access, which means we have a lower price, but it will take longer to retrieve the data. We can also change it to deep archive, which will have an even lower price, but it may take a while, even up to hours, to retrieve the data. There are various storage classes, but for a web application and the bucket that stores the web application files, we want to have the fastest storage class possible, even if it means paying extra cost. Because the longer the website takes to load, the poorer user experience we will be providing. We can also choose to encrypt the files. It is a good practice to encrypt files that are stored in an S3 bucket. For convenience, we are using managed keys, but we can choose to enable a custom key. There are other properties we can explore like checksums, tags, and metadata, but for the purpose of this overview and the web application, we will not be going into these into further detail. We can also specify permissions for an object. These are the permissions that are currently set. As an owner, we have read and write access for this object. We have also defined the permissions of what it would be to give public access to everyone and the users that are authenticated into our account. We could choose to edit the permissions for each object individually, or we can have them inherit the permissions that the bucket has. As you see here, the object inherits the permissions from the bucket. If we had version control set up, versioning enabled, we would see the different versions here. The benefit of having versions is if our data changes and we need to keep track of all the changes for record retention and for accountability, this would be one way to track it. Back at the bucket level, we're going to explore the properties. As you see, this bucket is located in AWS North Virginia region or US East 1. We have a ARN value. We have bucket versioning suspended for the reason mentioned earlier. We could choose to enable MFA delete. That way, when we want to delete an object, we will have to verify with MFA. But for the purpose of this web application, index HTML files and other supporting HTML, JavaScript, and CSS files and other static files should be changing often. Requiring MFA to change our website may seem a little strict for what the website is meant for. I moved down to the bottom of the properties. There are many other ones that we could explore, but for the purposes of this overview, I will focus just on some other ones. Object lock is a feature we can use to prevent changes to our files. When we enable object lock, we will not be able to delete or overwrite an object. Enabling object lock is a good thing to turn on, for example, audit logs, where we need to have proof that the log was not tampered with. Since our website files are expected to change very often, we will not be enabling object lock. Static website hosting here is disabled. We could enable website hosting to allow S3 to serve the website. If we do use the S3 website hosting feature, we will not have HTTPS enabled, and we will not have the benefits of a cloud delivery network. We will use CloudFront to provide content delivery network and to provide the web hosting feature. For that reason, we are disabling website hosting. In the permissions, we have public access blocked. You may be wondering how we can serve a website if public access is blocked. We could not even see the book cover image. As mentioned earlier, we will be using CloudFront to provide the website feature. Here we have provided a bucket policy to allow CloudFront to read the S3 objects. Rather than the website browser getting the data directly from S3, it will get it from the CDN cache or the CDN retrieval from CloudFront, which gets the data from S3 bucket. Here in the metrics tab, we can see information about the bucket. It can help us keep track of our usage and how many objects we have. If we see more objects or more usage than we expect, then it would be a reason to investigate. You can use management to automatically delete old data and also to replicate bucket. The lifecycle rule allows us to define how long objects are allowed to stay in the bucket before they're soft deleted and then a hard delete. Replication rules allows us to duplicate the content to a different region. We will not be using access points in our serverless application. Therefore, we will not go into this feature. And that's all for S3. In this section, we will cover CloudFront distributions. Here you see the distribution used for the Mastering AWS Serverless book website. In the details page, we see the automatically generated distribution domain name. We can visit this automatically generated domain name on a browser. As you see, the auto-generated name has a certificate. You see the lock on the address bar, and our website loads, meaning it's getting the information for the website from the S3 bucket. You will also notice the ARN. We have also specified custom domain names, which include mastering AWS Serverless book.com and the one with the www prefix. We have also created a custom SSL certificate. That way, when we visit the website, we will see that it's protected. When we visit the website, you will notice we have a lock in the address bar, meaning that it's an encrypted connection for the website. We have also specified index.html as the default root object. That means when we visit the auto-generated distribution domain name or our custom domain names, CloudFront will automatically try to get index.html object from S3 bucket. If we specify a path such as /by.html to our website, that will tell CloudFront to get the by.html object from S3. In the security tab, you see we have not enabled a web application firewall to protect our web application. For the purposes of this course and in the book, the WAF was not enabled to save on cost and complexity. It is a good practice for security to have a WAF enabled, but this course does not focus on cybersecurity in too much depth, therefore the WAF was not enabled. Since it is a good practice, it would be wise to learn how to configure a WAF after completing this course. We have specified an origin of the address for the S3 bucket for the book. The origin tells CloudFront where to get the information to cache in the CDN and also to deliver if it's not cached. We also have a behavior such that if there are any HTTP requests, meaning they're not encrypted, it would be automatically redirected to HTTPS, so therefore it has encryption from the SSL certificate. In the error pages section, we can specify the error.html object if we had one to show a custom error page. Invalidations allows us to clear the CDN cache for everything or just one specific path in the address path. We want to use an invalidation every time we change the files in the S3 bucket. Otherwise, the distribution will be returning old copies of the website. And that's it for CloudFront. Next, we will review API Gateway. Here you see the API that was created for the Mastering AWS Serverless book website. The website is a REST API with a regional endpoint type. Let's explore the API. As you can see here, this API has several endpoints or resources. It has a slash, which is the top resource. Next is the /account/info path that has options and put methods. Next we have /analytics/auth-callback, which has options and post methods. Last, we have the /chapters resource, which has get and options methods. As you see here, the options integration type is a mock. The reason we have an options method is because we will be using cross-origin resource sharing, or CORS for short. We need CORS because our website will be on one domain and the API will be on a different domain. When a web browser tries to make a request to an address on a different subdomain or domain, it needs CORS. The options mock will return a static response that will satisfy the CORS. The GET is a Lambda integration, meaning that when the request comes in, it will redirect or forward the event information to a Lambda function. Let's explore these integrations. Here we have the GET method. As we see, the client will send a request to the API gateway, which will then be sent to an integration request that will send it to a Lambda function. The Lambda function will return a response, and we'll use the proxy integration to send the response back to the API gateway, which will then send the response back to the client. The method request settings show that there's no authorization. For this endpoint, we will be returning just chapters information, not sensitive user information. Therefore, we do not need authorization. The integration request settings show that we will be using the get-chapters Lambda function for the integration. The API gateway will time out after 1 second. After 1 second, if the Lambda function has not sent a response, the API gateway will send a timeout. Since this is a proxy integration, we do not need to configure an integration response, since the API gateway will just return the response that the Lambda was sent. Here in the method response, we define that the response will be application.json format. In the test tab, we can specify query strings that are in the address or headers that are in the request and test to see what the response would be like. For the options method, we see when the client sends the request, it does the integration request and sends it to a mock integration. The mock integration sends an integration response to the API gateway, and the API gateway responds to the browser. The method request settings show that, again, there's no authorization. Since this is just CORS, we do not need to authorize CORS. What CORS does, it tells the browser to trust the response from the different domain. Integration and request settings show that the integration type is a mock. Further down, we see that we're setting a mapping template where we expect the status code to return 200. The integration response defines how the mock will respond. Since the mock is a static response, here we will set the CORS headers. The CORS headers state that the access control allow methods will be get and options, and that the allow origin is asterisk. The method response then translates the integration response in a way that the browser can interpret it. As you see here, the response will parse out the headers for CORS. When we have made all the changes to our API, we need to deploy it. To deploy it, we need to have a stage to associate with that API. Here we have the stages that we have defined for the API. We have defined the stage to be V1. The purpose of a stage is that we can define different versions or deployments of an API gateway. One way to define stages is to use versions. By using V1, V2, V3, we can deploy a version 1 API with a certain schema. In the future, when we decide to deprecate or add endpoints, we can update to a version 2. This allows older clients to use a V1 while newer clients use V2. It also supports backward compatibility in the event that some clients need to roll back to a version 1 because they are not ready for a version 2. We can use authorizers to verify that the request is coming from an authenticated user. This authorizer we created uses Cognito. API Gateway expects that there's a header that has the authorization information, like a token. The authorizer will get the token from the header and verify it against Cognito. If Cognito verifies that the token is valid, then it shows that the user is authenticated and is valid. API Gateway will then allow the request to proceed. Otherwise, it will return an error and prevent the request from proceeding. We want to use authorizers when we're dealing with user information or with any information that requires a logged in user. We can also configure gateway responses. There are many defined by default. Models allows us to define requests and responses in the API. They come in handy when you use standards such as OpenAPI or Swagger to define your API. As you can see, this empty model shows a schema. The schema shows that the input or the output will be an object. As we noticed earlier, we saw that there were schemas that use the empty model. The error model shows a schema that shows an object that has a message property with a value. We could use this error model when we return errors from the Lambda function in the API gateway response. A resource policy allows us to put access control to the API. Suppose we wanted to restrict our API to be accessed from only a certain IP address range. For example, if the IP address range matches the on-premises site for a business. By using this, you can limit access to the API to the users that are on-premises. The documentation tab can define how the API is designed. The documentation is similar to OpenAPI and Swagger standards. We can define the description for what an API does and for each of the resources and their methods. As you see here, the slash chapters is described as the getBook chapters. This gives the developer information about what the purpose of the API endpoint is. The options method is described to be for cores. The dashboard shows us metrics on the API usage. The API settings page shows us information about the API. We can see the ARN address for the API. We see the automatically generated API gateway domain for this API. If we want to have a human readable or easy to remember domain, we will have to create a custom domain. As you see, the default or our custom domain is different than the website domain. Therefore, we needed cores. Here we see a custom domain, api.masteringawsserverlessbook.com. It is a subdomain of the website. As you see here, we have specified a certificate for this custom API domain name. This allows us to have SSL encryption or TLS 1.2 to protect the data. We have configured an API mapping so that this custom domain will use the version 1 stage of the website API. VPC links allows us to connect an API gateway to a VPC connection. This is particularly useful if the API needs to access on-premises resources. For the purposes of this course, we will not be working with on-premises resources. We can also define usage plans. If we were to create a usage plans, we can enable rate limiting and quotas on how many API endpoint requests we're going to allow. Usage plans will definitely come in handy as your website usage increases. But since we are just creating a demo website application in this course, we will not be using usage plans. Another way to authorize API endpoints is to use API keys. An API key is a static value that will be used in the authorization header of an HTTP request to the API gateway. Any API endpoint that expects this API key will verify that it matches the value in the request. If the value matches, it will allow the request to proceed. Otherwise, it will deny it. Another way to authorize HTTP requests is to use a client certificate. The client will need to have the matching certificate installed on their machine. When the client makes a request, it will use a certificate to authenticate to the API gateway. When we create a certificate, we will generate one, and it will provide us the certificate we need to distribute to the clients. Having certificates is a good approach when you have known devices that you want to authenticate. Since we want anyone in the world to access our website, we will not be using certificates. We can also enable logging. By enabling logging, we can get logs of every HTTP request made to an API gateway. This is similar to having logging turned on a web server. And that's it for API Gateway. In this section, we're going to review CloudWatch. As you see here in the console, CloudWatch has many different features. One feature is the dashboards. We can create our own custom dashboard for things we want to track. We can also use the automatic dashboards that AWS provides. CloudWatch also provides alarms. We can create an alarm, for example, when we have an excess of 500 HTTP status codes. Another reason to use alarms is if we have a DynamoDB table with provision throughput. We will use the alarms to notify us when the throughput exceeds the provision throughput. That way we can keep track of how often the throughput is exceeding, and we can make adjustments to the throughput. One important alarm to create is the billing alarm. This will allow us to know when our bill is expected to exceed a certain amount. This way we can avoid a surprise AWS bill. An important feature are the log groups. Whenever our Lambda function writes to console.log for Node or uses a print statement in Python, for example, it will automatically create a log. Rather than waiting for the log group to automatically create, we can create it ourselves. The log group follows a specific format. The name should be /AWS/Lambda/ the name of the function. It should match the Lambda function name exactly. A benefit of creating the log group is that we can set the retention period and any anomaly detection. Even if we do not created ourselves, we can still set them. By default, the retention period is set to never expire. CloudWatch will bill us for the amount of storage the logs group has. We should update the retention period to match a duration that allows us to look at the logs as often as we need to while minimizing the amount of storage and therefore reducing the bill costs. We can update the retention period by clicking the value shown in the console. We will get a modal dialog to update the retention period. We can set the retention period to what makes sense. If we have a requirement to keep logs indefinitely, then never expire is what we should use. For most organizations, the maximum retention period for data is typically 3, 5, or 7 years. For the purpose of this course, I have set it to 1 week to reduce cost. When we click on a log group, we will see a log stream. These streams are the logs written by the Lambda function. Right now the log stream is empty because the application has not ran the Lambda function in a very long time and the retention period is very short. Another nice feature with logging is a live tail. We can choose the Lambda functions that we're trying to have a live log stream. This comes in handy when trying to troubleshoot an error. CloudWatch provides metrics. There are various metrics that come out of the box. Let's explore the automatic dashboard for DynamoDB. As you see here, there are metrics that come out of the box in a pre-built dashboard that can come in handy. The consume read capacity units and the consume write capacity units will allow us to understand our database usage. We can leverage X-Ray to understand our invocation. When we enable X-Ray across our application, it will tell us what happens from start to end. For example, when a web browser uses a web application that we built and the web application sends an API request to API Gateway will put an X-Ray trace ID in the event. And let's say the API Gateway invokes a Lambda function. The Lambda function will get that event. If that Lambda function makes a read request to DynamoDB, the X-Ray ID will propagate. And if that Lambda function sends an event through EventBridge, that X-Ray ID will be passed along. So if we have a trace ID, we can put it in here and track path from start to finish, and the trace map will show us our invocations as well. As you see here in the menu, we have an events drop-down. The rules and event buses used to be called CloudWatch. Now it's called EventBridge. If we click on it, it will take us to the EventBridge service page. We will review EventBridge in the next section. Amazon EventBridge allows us to create event-driven applications. Events and event-driven architectures are at the core of serverless computing. In this course, we will mainly focus on schedules. When we create a schedule, we will focus on recurring schedules. This will allow us to trigger a Lambda function that we have specifically designed to be triggered on a schedule. I will give this schedule a name, daily-lambda-schedule. We have the choice of a cron-based or rate-based schedule. Cron is a service used in Linux operating systems. Let's say we want a Lambda function to always trigger at midnight. We will specify that it will trigger on the 0 hour and the 0 minute. That is exactly midnight. We will specify that it can run on any day of the month. As you see, the day of the week was automatically filled for us. We will specify that it will run on any month, and we will specify it will run in any year. The console will give us the next 10 trigger dates so we can verify that it works as desired. We can specify the flexible time. If we need this schedule to run exactly at midnight, we will set it to off. But if we need it to run any time during the midnight hour, we will select the 1 hour flexible time window. We can also specify when we want the schedule to start and end. The time frame comes in handy when we want our schedule to only run during a specific time of the year. In the next step, we will specify what we want the schedule to invoke. In this example, we want to invoke a Lambda function, and we select the Lambda function that we want to invoke on this schedule. We can also specify a JSON payload for this Lambda function. We have created a payload with an application property and an acronym value of mastering AWS Serverless, MAS. This way we can configure and code our Lambda function to look for the event payload, verify that it has an application property, and the value is MAS. We can also add other logic to verify verify that the event source is from EventBridge. We do this to perform input validation for Lambda function. We should inspect every event to make sure that we received the intended event. In the next step, we can choose to enable the schedule. We can choose to delete the rule after all the scheduled invocations have finished. We can specify a retry policy such that it will retry to send an event to the Lambda function if it has received a failed invocation response. Sometimes the Lambda function might throw an error unexpectedly, and retrying again will result in a successful invocation. We should consider adjusting the maximum age event and the retry attempts to match our business logic. If the maximum age or the maximum retry attempts have exceeded, we can choose to send the event to an Amazon SQS queue, which can then send us an email notification or some other response so that we know something is wrong. We can choose to encrypt the data payload for additional security. We can ask the AWS console to create a new role for us, or we can use an existing IAM role that we have created for this schedule. In the last step, we will review the settings and click the Create Schedule button to create the rule. And that's the overview of EventBridge for now. In this section, we will review Amazon SNS. Here in the dashboard, you can see I already have 2 topics and 1 subscription. These were created when writing the Mastering AWS Serverless book. As you see here, we have 1 topic to send an email and another topic to send SMS. The send email topic has a subscription for the Lambda function called SNS-send-email. To help identify the topic, it is named after the subscription and function that the topic is meant to use. The topic requires an access policy. It is very similar to an IAM policy, but it is defined within the SNS topic. We also have other settings we can modify: the data protection policy, the delivery policy, logging for delivery status, encryption, any tags that will help us with billing and app organization, and whether we want to enable X-ray active tracing to allow X-ray to track an invocation from start to finish. As you see here, this is a subscription from a Lambda function. We can use this page to subscribe to topics. If we have a mobile application, we can enable push notifications. When we create a platform application in order to send push notifications, we can set up Apple Firebase Cloud Messaging, which is used for Android, Amazon device messaging for the Amazon devices such as Fire. This way we sent an event to an SNS topic, and that results into a push notification on the mobile device. It requires setup with the provider. For example, an Apple secret key will need to be generated from the Apple developer platform. We can also send text messages. Text messaging by default starts in a sandbox mode. We can enter our own mobile phone number, which we will need to verify. This way we can test the SMS functionality. If we need to send text messages for our application, then we will need to exit the sandbox mode and start the application process to request AWS to allow us to have production access. In this section, we will review the simple email service. SES allows us to send emails for transactional or marketing purposes. When we first start using SES, we are in a sandbox mode, similar to how it was for SNS text messaging. To get started using the sandbox mode, we need to define identities. As you see here, I have verified the domain name and the email address I will be testing. To verify the domain name, we need to create a DNS record. We will add a DKIM record to our DNS. To be more precise, we will be adding a CNAME record to the DNS to verify the DKIM settings. If we are using a Route 53 hosted zone, we can ask SES to create the DNS record for us. Otherwise, we will need to copy the name and value to our DNS service. When we are ready for production access, we will need to make a request with AWS support. Let's explore Amazon Cognito. Here we see one user pool that I created for the Mastering AWS Serverless book. This user pool shows the information on the overview page. Here in this section, we see an app client that I had created for this Cognito pool. The client was for the website masteringawsserverlessbook.com. The app client page shows us examples on how to set up the app client. It also shows us the add attribute permissions that were enabled and disabled for this client. And we configured the allowed login pages, callback URLs, and sign out URLs. When Cognito gets a request from a web page and the URL does not match these authorized URLs, it will deny it. You can also activate threat protection for an additional service fee. And we can also enable analytics for an additional service fee. As we see here, some users have signed up for our application. We can manage a user by clicking on them. Since this was a test website to show functionality, I am going to sign out the user. I will confirm that I will sign them out, and now the user has been signed out. Next, I will disable their user access. I will confirm that I will disable it, and now the user has been disabled. We can also create groups to give users different functionality. For example, we can have an admins group, and our web application will check whether the user is in the admins group to enable admin functionality. We can specify how we want the users to authenticate. We can allow email and SMS and passkey login. We can also specify the password policy. In the sign-in settings, we can specify how we want the users to log in. Here I have specified email. We can also require that MFA be enforced. If they have not set up MFA, they will not be able to log in. We can also configure the sign-up experience. If we want to allow users to log in using federated identities, we can enable that. Cognito supports Facebook, Google, login with Amazon, sign in with Apple, SAML, which is a custom integration with an identity provider such as Okta, and OpenID Connect, which is also connected to an identity provider. We can also configure a custom domain. Rather than using the AWS provided web address, we can create a custom domain such as auth.masteringawsserverlessbook.com to make it easier to code in the web application. And it would also make it more credible to the users since there is a custom domain rather than an automatically generated domain. Let's explore Certificate Manager, or ACM. Here in the List Certificates page, you will see the certificate for the masteringawsserverlessbook.com website. Here you can see that this certificate is eligible for renewal, meaning AWS will automatically renew the certificate rather than me having to manually renew it every year right before it expires. This certificate verifies the top level domain, which is masteringawsserverlessbook.com, and any subdomains such as auth.masteringawsserverlessbook.com. If we were not using Route 53, we would have to put these CNAME records in our DNS. Since we are using Route 53, we could create these records by clicking this button, and every renewal, AWS will automatically do this for us. Here in Route 53, we see we have one hosted zone. The hosted zone is for the masteringawsserverlessbook.com domain. I have chosen to use a hosted zone for the top level domain. We could create hosted zones for subdomains as well. For simplicity, I just chose the top level domain. We can inspect the records for this hosted zone. AWS will automatically create the SOA, or Start of Authority record, and the NS, or Name Server record. The rest we add based on our application needs. This is an A record that points to the CloudFront distribution that serves the website. This is another A record that allows us to have a www address for our website, and it points to the same CloudFront distribution. This A record for the auth subdomain allows us to have a custom subdomain for the Cognito login, and this A record allows us to have a custom subdomain called API for our API gateway. Another benefit of using Route 53 is that we can register domains with AWS. If we want to have all our application billing on AWS, we would set up and register a domain in Route 53. When we create and register a domain in Route 53, it will automatically create a hosted zone for us. Here we have the IAM dashboard for the AWS Identity and Access Management Service. We can use user groups to give us access to the AWS console or through programmatic access for CLI tools. Here we have a user that allows us to do any deployments via the AWS CLI in a terminal. Currently, there are no users assigned to this group. If we do assign users to this group, they will have these permissions. The Access Advisor will tell us what permissions are actually being used. Here we could create a user. We're going to create a temp user. Since this user is meant just for using the CLI, we will leave access to the Management Console unchecked. Here we can choose to add this user to the group, and then we create the user. The user has now been created. For security reasons, it is good to assign an MFA device to the user. That way the user will require MFA before being able to access AWS. This section shows all the roles for our AWS account. Let's explore a role for a function. As you see, I named my roles to give me an indication of what they are for. This role is used for a Lambda function named get-chapters. This role has an IAM policy associated with it. The policy is named after the role. When I click the policy, it takes me to the policy page. Here we see the policy provides write access to CloudWatch logs and read access for DynamoDB. We can also view the policy in the JSON format. Here in this JSON format, we can see the actions and the resources allowed to be used. It is a good practice to define IAM policies such that they are least privilege. This way, if a resource ever gets compromised, the blast radius is smaller. If we have an action of asterisk and resource asterisk, this Lambda function would be able to access all of AWS with full administrator rights. Here, this function only has log and DynamoDB permissions, specifically to scan a table, which is called chapters, and to create a log stream and put log events for a log group called /AWS/Lambda/get-chapters. And that's it for this chapter of the Mastering AWS Serverless course.